All right. Well, one more time, welcome to our session on En-ROADS today. Good morning, good afternoon, good evening, wherever you are joining us from today. I know folks are from all different parts of the world. I'll quickly introduce myself in a moment, but just telling you a little bit about what the session today is about. So En-ROADS is a simulator which allows us to build scenarios for what the future might look like, depending on what solutions uh, we put into play for climate. And we're going to kind of spend a lot of time looking at the simulator, and you'll get a chance to hands-on play with it as well for some time. So all of that coming up in session. Just a quick note before we start again. I'd love to have you on camera, or as many of you who can switch your cameras on, please do. Always lovely to see your faces as we're all interacting and speaking and discussing. Uh, it's very hard to speak to black rectangles on the screen. So thank you. If you can switch your cameras on, that'd be really lovely. All right, quick introduction. My name is Ashwin, and I see a few familiar faces. And if you've met, hello. So my name is Ashwin. I've been an instructor with Terra for the last 2 years now, and just over 2 years. Um, a little bit about my background. So I now live in Goa in India. We have a farm close by, which we are just about getting started building up as a permaculture project. Before this, I've worked in tech for about 10 or 12 years, mostly in the AI, machine learning, data science space. So that's me. I came to Terra to take the LFA course, the flagship course that Terra offers on climate change, which is a 12-week fellowship, the LFA. So I came to Terra to take this fellowship 2 years ago, and I never left. I've been instructing ever since. Uh, a little bit about Terra in case this is your first encounter with us. So Terra was founded about 4 years ago with a mission to bring 100 million people working on climate by the end of this decade. We offer a variety of different courses. The biggest one is our flagship course, Climate Change Learning for Action. And I see a few familiar faces from the course here as well. So welcome all of you. So this 12-week course gives you a journey into the climate space, starting with the science, the impacts, the systems, which are kind of crucial in the solutions, and also all different sectors in which we need to do work, like energy, food and farming, and so on and so forth. So that's the 12-week course. We also offer smaller 4 to 6 week courses on specific interest areas, like maybe ESG or carbon accounting or AI, and so on and so forth. So that's about Terra. Now, coming to our session today, as you're getting started, and I'm going to show you the simulator in a second and walk you through what it looks like and how it functions. But even as we're getting started, a couple of things to note. I think the calendar invite for this meeting said 90 was for 60 minutes, but the session is designed to run for 90 minutes. So what I'm going to do is I'm going to try and make sure that we fit most of the session in 60 minutes, but we'll keep going beyond till 90 minutes. So I'll be around for the whole 90 minutes, and we can keep kind of continue playing around with it for the whole time. Just in case somebody needs to leave at 60 minutes, we'll try to fit most of the session into 60 minutes. Yeah. So as we're getting started, I have a request for all of you. You've probably been kind of thinking about or reading about climate and the different solutions that are on offer. I want you to tell us, maybe use the chat window for this. So go into chat and type in what are the most impactful climate solutions that you have come across, things that you believe in, things that you feel are going to be most impactful, right? So just go ahead and chat and type in, what do you think are going to be the most impactful climate solutions that we should really double down on in the next few years or decades? So go ahead and type that in, and I'm going to, in the meantime, share my screen and show you what the simulator looks like, and then we'll go from there. So again, in chat, just put in what is the one or a few solutions that you feel are going to be most impactful. Smart agriculture, reduced emissions from factories and power stations. Okay. Distributed energy, the political will, yes, of course. Carbon price, support for renewables, for storage, rework our food systems, biochar. This is great. This is exactly the kind of things that I was looking for. I just want to get a sense of you know where your mental models are at in terms of solutions. Permaculture, yeah, that's one of the key solutions as well. All right, keep those coming. And while you're kind of still thinking about that or still putting those into chat, I'm going to share my screen and show you what the simulator looks like and walk you through some of the different components of the simulator. Um, So this is the En-ROADS simulator, and I know there's a whole lot of things going on the screen, but we're going to kind of go through this in detail. I'm going to walk you through those different components. Um, so let's start with, before we start with the specific things that you see on the screen, a few things to know about the simulator. The simulator is built by Climate Interactive in association with MIT School of Management, MIT Sloan School of Management. Climate Interactive is a nonprofit, and they're doing this to educate all of us about climate and its impacts. And it's a very powerful simulator. It runs in the real time. It's based on systems dynamics. There are more than 14,000 equations running in real time in the background as we move these sliders around. So it's pretty complex. It's built using the latest available science from international bodies like the IEA, the International Energy Agency, the UNFCCC, and so on and so forth. So this is kind of built on the latest available science. The thing I like most about the simulator is two things, actually. Number one, they're completely transparent. So whatever assumptions, policies that are kind of in the background aren't hidden from you. They're completely available for anybody who wants to look at them. And I'm going to show you how to look for them in a minute. But they're completely transparent about all the policies and assumptions that they are kind of using or having baked into all of these models. So that's the first thing that I like about them. They're transparent. And this model is extremely flexible. So you can actually go in and change all the basic assumptions, all the policies, anything that you feel should work differently or does work differently, you can actually go in and model all of that. So it's not set in stone by the makers of the simulator. You can actually go in and change whatever you like and as much as you want. So these are a few things to know. It's built from the latest available science. It's extremely transparent. You get to see everything you want to in terms of the workings of the simulator, and it's flexible. You can change things around. It's not like a black box where you don't know what's happening inside, right? So that's about the En-ROADS simulator. Now, what are we seeing on the screen? Lots of different things. So let's start with this chart here on the left, which talks about global sources of primary energy. So this is talking about how much energy do we use as humanity around the world every year. The unit is exajoules per year. Um, and we are seeing energy use growing through the rest of the century up until 2100 and very likely even beyond, right? Now, the question is, what are we assuming here? So we are assuming business as usual. The simulator is saying if we continue along the path that we're already on, and it's also taking into account policies that have been enacted across the world for the future. So, for example, renewables are scaling up, and you'll see that green wedge, which is renewables, scaling up. So that's already baked in, right? Because we are already seeing this happen. Because there's lots of policy around the world which is kind of investing in renewables. You're already seeing that baked into the model. Renewables are already scaling, right? So this is taking business as usual and saying, this is one possible uh, estimate of how much energy we will use year by year over the rest of this century. Now, this is not making a prediction. None of the numbers you see here are predictions. It's not trying to guess. It's just using whatever policies that have been enacted, whatever's already happening, and projecting forward, right? So please don't think of this as a prediction tool that you can put you can move some sliders around and predict what the temperature might be at the end of the century. That's not the intent of the tool. So the first chart is how much energy we use and why is energy up there. So, there are many different sources of greenhouse gas emissions, but energy is the biggest one. More than 70% of our greenhouse gas emissions come from our use of energy, right? So that's why the global sources of primary energy is up here on the left. The second chart here on the right, the much simpler looking chart, is how much CO2 or how much greenhouse gas are we emitting every year into the atmosphere. And you will see we are somewhere in the 58, 59, maybe about 60 gigatons uh, per year, right? So we are emitting roughly about close to 50, 58 point something gigatons of CO2 into the atmosphere every year. And as this keeps on growing, we continue to warm more and more. Our goal is to take this number down to zero, right? So our goal is to bend this graph, if we can, in any way, downwards, and bring it as close to zero or even to zero, if we can possibly make that happen. The number on the right, this 3.3, is the amount of warming that we should expect if we are if the scenario on the screen comes to pass. This is how much warming we will end up with by the end of the year, by the end of the century, right? So 3.3 degrees. Would anyone want to tell us how much we want to limit this to, or what does the Paris Agreement say? What number do we want to stick or not allow to go beyond? You can use the chat or unmute, whatever's easier. Yeah, 1.5 and not past 2. That's absolutely right. So what the Paris Agreement, yeah, in degree C, what what the Paris Agreement says is we will do everything possible to limit it below 1.5, but 2 degrees is also part of the text of the Paris Agreement. So the Paris Agreement started off with this 2 degrees, but then they later amended that statement to say that we will do everything possible to limit it to 1.5. So what we're going to try to do today is play around with different policies and try to keep this number to below 1.5. Yeah, so that's going to be a goal that we'll try to achieve in this session today, right? Now, how do we make an impact on this? Well, all the sliders you're seeing on the bottom half of the screen, as we move them around, you'll see all of these charts changing, all of the numbers changing as well. So what are these sliders? The first block of sliders on the left here is on energy supply. Where does our energy come from, right? The chart on top is showing you how much energy we use, and it also breaks it down by source. And these are some of the sources. These are, in fact, all of the sources or all of the major sources of our energy. You'll see the traditional fossil fuels, coal, oil, natural gas, but there's also renewables. There is nuclear. What is new zero carbon? Now imagine there is some technology somewhere sitting in a lab in the world somewhere today in a research lab that's being worked on, and we are expecting that energy source to come online maybe at some point in the future. So that's a new energy source which we don't have online as of yet, but we are hoping will come online and will kind of be zero carbon, right? It's something that does not emit any carbon into the atmosphere. So the simulator also allows us to model out kind of hypothetical situations of what if we are able to bring some such source online. So the sliders on the left are energy supply. The middle section is our demand for energy. Where do we use all of that energy? So there's transport, there's buildings and industry, and then there is growth, right? How much energy we use is very, very dependent on how many people there are on Earth. The more people, the more energy we use, and how fast we grow or how much we grow, right? So those are two key drivers. And then, of course, there is, how much energy we use depends on how much our buildings, industry, and transport infrastructure end up consuming, right? So those are the first two blocks. And the third block up here on the right is talking about other sources of emissions and other ways in which emissions can be impacted, not energy, but something else. The first couple of them are talking about carbon dioxide removal. So there are technologies which allow us to actually pluck carbon out of the atmosphere, either using technology or by planting trees, for example. And then there's a whole host of other greenhouse gas emissions. Again, these are emissions which come from other sources or sources other than energy use, right? So agriculture is a major source. As we expand our agricultural footprint, we are kind of cutting down a lot of forests, and that is one of the key areas, key ways in which we're emitting greenhouse gases. There is waste and leakage. A lot of natural gas, methane, gets leaked into from our fossil fuel infrastructure. So there's that, and there's deforestation, right? So this is what the simulator looks like. Now, as we began, I had asked for a few suggestions on, what are the different policies or what are the different things that you feel optimistic about. Now, the way to use the simulator is to test our mental models, right? So, for example, someone said that we should invest in renewables because that is one of the kind of technologies that I personally believe very strongly in. Now, one way to use the simulator is to test that out. What if we take renewables and we invest heavily in it or we incentivize it heavily? So if we move this slider on the right, it means that we're incentivizing renewables. We move it to the left, we are disincentivizing. So encourage towards the right and discourage towards the left, right? So the suggested policy is that what if we invest heavily in renewables, we incentivize it heavily. So I'm going to, in a moment, move this slider all the way to the right, right? Really, really put our backs, put our kind of energy into renewables and say, let's push as hard as possible on. Question for all of you. Once I move the slider completely to the right, how much do you think this number, this 3.3, is going to be impacted? In degree C, how much will be able to lower it down by? Will be able to bring it down by 1 degree, half a degree, 2 degrees, or some other number. Just go ahead and put into chat your prediction or how much you think incentivizing renewable energy will kind of move that number downwards. Less than 0.5, okay. 2 degrees, okay. I'll wait a few more seconds before I pull that lever to see what are the predictions coming. 1 degree, okay. 1, all right. Okay, so looks like we have a range from 0.5 to 2. So let's actually pull that lever. I'm going to pull it all the way to the right. Keep an eye on that number on up on the top of your screen, that 3.3. Let's see where that goes. All right, ready? So here goes. How much did it go down by? Just 0.1. And I'm guessing that's surprising for a lot of us, and it was for me when I first looked at it. And then we're like, what just happened, right? Renewables is one of the key areas. Like we talk about the renewable energy transition and how well we're doing on this. And even if we push heavily on that, we like really encourage it and incentivize it. We're only getting 0.1 degree. What just happened, right? Well, let's replay this a few times and see what happens. Just look at those two graphs, right? As that lever gets pulled, let's see what happens on those graphs. Yeah. So one of the things that you might have noticed is the green wedge, which is renewables, that does expand quite a bit, right? So that does kind of grow quite a bit as we pull that lever, which is great, which is exactly what we wanted. But what also happened was our total use of energy increased, right? So this graph, which is going upwards already, I'll replay it one more time. So the total amount of energy we use also increased. Yeah. So what we want when we kind of incentivize renewables is for renewables to replace our fossil fuel energy use. But what's actually happening is renewables is scaling up, but coal, oil, and natural gas aren't really going down. I mean, it's reducing a little bit, but not really going down. And what's happening actually is we're increasing how much energy we use in total. So just incentivizing renewables by itself may not give us the result that we want, right? That's kind of the takeaway from this. That said, I'm not saying that investing in renewables is not something we need to do. We probably need to do a whole lot of that. Just that by itself is not the answer. Yeah. One of the other things somebody talked about in chat, if I remember right, was fossil fuels. How can we kind of get away from fossil fuels as soon as possible? So we have these three up here, and I'm just going to show you coal. Again, I'm going to pull this lever for coal all the way to the left, which means we're going to disincentivize coal as much as possible, right? We're going to maybe tax it, maybe do some other things, but we're going to make it way harder for coal to be used to produce our energy. Now, again, looking for predictions on how much do you think this will have an impact? How much, like if I pull this lever for coal all the way to the left, by how much will this 3.3 go down? Any predictions? 0.1. Okay. Now we know what the scale at which things move. 0.3. Okay. Any more numbers? 0.2. Okay. So it looks like we have kind of tempered our expectations now after looking at the first slide, which is fine, which makes sense. Okay, so I'm going to pull this lever all the way to the left in just a moment. Yeah, ready to pull this lever. And again, as usual, just keep an eye on that number. Okay, it went down by about 0.2. So looks like we were right on the money in terms of our predictions. And again, I'm going to replay that change a few times so that you can see actually what's happening. Just keep an eye on those charts while the change is replayed. What are we seeing here? We're seeing the band for coal, which is the one at the bottom, the maroon band at the bottom, that kind of gets pinched down, which is great, which is exactly what we wanted. So we want coal to become harder to use as an energy source, and that looks like it's happening. The amount of coal we use reduced. The amount of total energy also reduced, right? You'll see that um, the graph kind of all of it shifts down, which means the total energy we use also reduces. Maybe good, maybe bad, something for us to think about. But why did it then only give us 0.2 degrees of impact? Now, again, just keep an eye on what happens with the green, blue, and red lines. So the renewables, natural gas, and oil lines or the wedges on that graph. So I'll replay it one more time and look at what happens there. If you notice, the amount of energy coming from coal has gone down drastically, and some of that has come from renewables because renewables did increase. But some of that has also come from more natural gas and more oil being used. So it's like we push the balloon in one point, it bulges out at another point. That's what's happening here. So even though we are reducing the amount of coal we use, some of that reduction is being covered by using other fossil fuels, kind of more heavily. So that's another thing to watch out for. Whatever policies we enact, we have to kind of think of all the possible aspects of how it might make an impact. Now, I see a couple of questions. I'm going to come to that. I see them in chat, and I'm going to come to those in a moment. Um, so a few things to remember about this simulator. Um, we have a couple of charts up here. There are a whole lot more. If you click on this, there's like a bunch more in there. I'm going to give you about 15 minutes in breakout rooms. In a moment, I'm going to send you off to the breakout rooms for you to be able to build out your own scenarios and kind of play around with this. And I'm going to give you more instructions about that in a moment, but let's maybe look at the questions. Um, yeah. So does the model consider fossil fuel expenditure that will display? So this model does not talk about investment. This does not talk about how much money is going to be required. Like, for example, we said, um, let's incentivize renewables. Let's push this slider all the way to the right, or let's push that coal slider all the way to the left, right? This model does not kind of model how much money this involves, how much money would we need to invest in renewables, or how much money would be raised by taxing coal. That's not part of the model. Um, One way, well, different things need different amounts of money, and it's harder or easier depending on what we're talking about. But one way to kind of enforce a financial constraint on whatever simulations you run is trying to minimize the number of levers that we use. Ideally, if you could use all of the levers and move all of them to the extreme, of course, we'll hit whatever goal we want to hit. But just to know that there are constraints in the real world, what we'll try to do is we'll minimize the number of levers that we put, right? So the other question about don't we have a finite energy expenditure so that when we increase renewables, won't fossil fuels be reduced automatically? Well, unfortunately, that's not how it works, right? Because our need for energies has been growing over the last decade, over the last century and a half. And if you allow it to, it will continue growing, right? So for example, when we pulled this renewables lever all the way to the right, we saw our total energy use go up and fossil fuels not really going down to zero, right? So we are not really replacing, we're just increasing the amount of energy that we end up using. Not all renewables are clean, I agree. Hydrogen, it depends on how that hydrogen is produced. So if the production of the hydrogen involves fossil fuels, that means you're using more of oil, coal, oil, natural gas. If it increases the use of renewables, then that's modeled through here. So that's kind of how it does not directly model how hydrogen might impact this, but depending on how that hydrogen is generated, that will have an impact on our emissions. Does this track regulations? No. So this model is policy agnostic in the sense that, like, for example, when we say incentivize renewables, that could be done in many different ways, right? You could have subsidies. You could raise taxes on something else and provide that money to renewables energy providers. Um, you could provide government, or the government could actually provide capital to set up power plants using renewables, things like that. So you can actually enact that policy in many different ways, and different countries will choose to do it differently based on their circumstances. But this model is completely policy agnostic. It just says if we push hard on a particular thing, what might that kind of give us in terms of impact, right? I'm sure there are going to be more questions, and we'll take those as well. But I want to give you a chance, you folks a chance to kind of play with the simulator. So I'm going to send you off into breakouts in a moment. A couple of instructions. There'll be about 3, 4 of you, maybe 4 or 5 of you in each breakout room. It would be great if one person shares screen. So if there's a volunteer in each room who kind of agrees to share screen, so that all of you are looking at the same thing, and then you can discuss, what levers to pull and what solutions to kind of incentivize. So that's one. The second instruction is use as few levers as possible. I would say limit yourself to 6 levers or fewer. So just like it's easy enough for us to pull a lever, but that actually means something in the real world. It's hard to do things. It's hard to get things done. So we'll simulate that constraint by saying that we are going to pull at the max maybe 6 levers. If you can pull fewer, that's great too. Our goal is to get this number, this 3.3, to below 1.5 or at least till 1.5. Yeah. So I'm going to create some breakout rooms right now. And I'll send you off into those breakout rooms. And like I said, if one person can share screen, that'll be great. I'm giving you a link to the simulator. And once you're done, I'll give you about 15 to 18 minutes in your breakout rooms to kind of build your scenario. Once you're done, don't shut the window. Whoever is kind of sharing screen, remember not to shut the window. Just share your scenario up here on the right top of your screen. You can actually go ahead and copy the scenario link, right? So you can actually copy that link. When we come back to the main room, we'll look at what your scenarios look like and maybe discuss what happened as you built your scenarios. All right, how does that sound? Good so far? Okay, so I'm going to open rooms now and I will see you folks back in about 15 to 18 minutes. And again, I'll jump into those rooms for a minute just to see how things are going. If you have questions, I'll answer those as well. But yeah, pull not more than 6 levers and try to get this number down to 1.5. That's what we're trying to do. Rooms are open, and I'll see you back in a few minutes. All right, folks, welcome back. How did that go? Did you folks make progress on our goal? Okay, I can see the thumbs up from there. All right. So I already have, so I have both scenarios, so both rooms with us. So how about we dig deeper into those scenarios and kind of dig deeper into what happened when you pulled those various levers, and maybe you can give me a flavor of what the discussion looked like. So let me start with the scenario that Jason shared. Hang on, give me one moment while I open that up. And yeah, I'm going to share screen, and then maybe somebody from that room can kind of walk us through what that scenario looked like. Okay, so Jason had to leave, but I believe Parimala, Curtis, you folks are there. So would you like to walk us through what the discussion was and how you went about this? Curtis, if you're speaking, you're on mute. We can't hear you.
Oh, sorry. Yeah, I'll start maybe, and we can share the discussion. I wanted to, mention the first lever that we used was the carbon price, and Jason and I kind of knew a little bit because we'd played with this a little bit before about the carbon price, which dropped it drastically. It basically taxed the other energy sources and very heavily, so the usage was decreased. Basically, it drew down on our carbon energy supplies. Yeah, so it made the other levers in the energy supply thing kind of useless, and that one was basically the silver bullet for that section. I don't know if I should keep going.
Yeah, please keep going. Just tell us, what your discussion was and how you went about achieving all.
The other kind of bigger, these other levers didn't make as big of a difference as the carbon price. That if the state I have it in, it made a 0.8 degree C delta, and all the rest of them made a 0.2 to 0.3 degree C delta. Unfortunately, we couldn't get to 1.5 with only 5 levers. Yeah, we just couldn't make it work. I think we could do it with 6. And I think Jason had energy efficiency dialed all the way up, but we can do it with just under transport, but we can do it with just the building energy efficiency, increasing that to the max, and then using both nature-based and man-made carbon removal technologies to the max, and reducing all of the kind of I guess they would be considered fugitive emissions, I suppose, from methane from cows and from landfills. So those are, like I said, roughly 0.2 to 0.3 degree contributions each. So the 0.8 plus 0.225 times 5 is 1.25 is like nearly 9.5. Sorry, 0.9 and a half, 0.95 degrees lower. So I suppose that I'm gonna have
Yeah.
to check my math, but that brings it to
That,
1.5.
all right. No, that's fine. That's great. Thank you, Curtis, for that. And quite a lot of interesting things that you tried and you talked about there. So maybe let's kind of look like one level deeper and explore what happened here. I'm gonna reset, or actually let me open up a fresh window. So this was the base scenario that we started off with, and the number was 3.3. And kind of the first lever that you folks started off was the carbon price. So I'm going to pull that lever all the way to the right. And like you said, it has like really huge impact, outsized impact. So 3.3 went down to 2.5 straight away. So let's kind of explore what happened here, right? And I'm going to pull up kind of a range of graphs up here on the screen, and I'm going to replay the change so you can look at what's happening um, as we increase the carbon price, right? So a lot of different things happening, but we'll kind of look at them one at a time. Our cost of energy is shooting up, right? So the black line is where we were in our baseline scenario. Adding a high carbon price or a very high carbon price, as what we've done right now, has kind of made energy really expensive. Yeah, so that's kind of one of the fallouts. And there are whenever we're kind of thinking about any of these policies, there's always one eye that we should probably have on justice and equity. So increasing cost of energy means economic hardship and energy deprivation for a large section of our population. So that's something that we have to watch out for, and we have to counteract using some other policies. So that's something to keep in mind. But as the cost of energy has gone up, you'll see energy consumption overall has dropped, right? So like humanity is going to use less energy overall over the rest of the century. And you'll notice that the cost of energy has grown like really high for oil, and for coal. The interesting thing is it goes really high and then it drops back down for coal and for natural gas. Any hypothesis on why that might be? Why would the price for coal and natural gas kind of go up drastically when we enacted the carbon price and then come down all the way here? Yeah, I mean, it's still higher than it used to be, but yeah, sorry, go ahead.
Some kind of efficiency in production.
Not really, because I mean, coal has been around forever. So whatever efficiency was, like, we've already gotten all of those gains. Again, this is my hypothesis, and I'm not saying this is the definitive answer, but as we are using lesser energy, kind of lower and lower energy, because the total energy demand is getting lowered, various different sources of energy have now excess demand, excess capacity available. And economics tells us that when there is excess capacity, producers will lower prices until that capacity gets utilized, right? Until they're making kind of marginal profits on whatever they're producing. So as we are using less energy, at some point, we have installed coal plants which are not running at 100% capacity. And so long as they're able to make even 1 cent of profit on each unit of energy that they provide, they will kind of reduce prices so that that energy gets consumed. So that's possibly what is happening, right? Now, because our energy is still becoming expensive and we are reducing the consumption of energy in one stroke, in kind of just using one lever, we have kind of an outsized impact on the overall temperature, right? 0.8 degrees Celsius. And what Curtis was already talking about, like after doing this, if I pull any of these levers, it doesn't really have any impacts, even renewables. Even if I pull it, yeah, sure, it increases that wedge, the green wedge a little bit, but that happens mostly by increasing overall energy demand. It doesn't really impact the temperature as such, right? So just in enacting a carbon price kind of takes care of all the levers on the energy supply side. Now let's pause and think about that for a moment. Pulling this lever is easy enough. I mean, it takes nothing, but actually enacting a carbon price, across the globe, so that all energy consumption from fossil fuels kind of gets taxed based on how much, based on the emissions intensity, is pretty darn difficult, right? And many different jurisdictions in the EU, California, and a few others, they've been playing around with this idea of taxing carbon or a carbon price, either a cap and trade scheme or a carbon tax or a few other variations. And everybody's been finding it really, really hard. And to think about having this happen across the globe, that's going to be a challenge. If you're able to get it done, yes, it will have a lot of impact. But the answer that might work in practice is that we have carbon price in some jurisdictions where energy use is really, really high, but we might also need to use some of these other levers. So the carbon price lever may not be pulled all the way to the right. It will maybe be somewhere in the middle, but then we will also use some of these other levers. We will maybe tax coal or incentivize renewables, incentivize nuclear, some of this, right? So while pulling this lever was easy enough and it gave us outsized impact, in the real world, it might not be that straightforward, right? So that's number one. The other thing, the other lever that the folks pulled was energy efficiency. Now, if you use energy efficiency on top of carbon price, you see there's still an impact. But if you didn't pull the carbon price and if you just did energy efficiency by itself, just keep an eye on that number there. You'll see you get to 0.3 degrees of impact, right? But if you pull it after the carbon price, you get only 0.2 degrees of impact. That's because by taxing fossil fuels and making overall energy already more expensive, you're already incentivizing energy efficiency to some extent, just by the fact that energy has become more expensive. What else? I think you had also pulled waste and leakage, and that's, I think, also something that gives you a lot of impact. Agricultural emissions, reducing them, land use change, emissions coming from excess utilization of fertilizer, that also kind of, and these two levers, the reason they have impact is because this is nothing to do with energy supply. So these do not get acted upon when we pull the carbon price lever. These are kind of other ways which are completely, totally different from our energy supply, which is why they're giving you an impact. And the other kind of insight that comes out of this is, we dealt with energy supply, we did a little bit with energy demand. We looked at agriculture, we looked at waste and leakage, but all of this together still does not get us to 1.5. So it's quite likely that we're going to need some carbon removal of some sort. And so, in the breakout room, you folks had pulled both nature-based and technological, and then you're gotten really, really close to 1.5. So a few different insights here. I think the last one was that we might end up needing some amount of carbon dioxide removal, either technological, nature-based, or both, as we go along. All right, so that was from the first, from one of the two rooms. How about we quickly look at the other room as well? And I know we are on the hour. If somebody needs to leave, thank you for joining, but we are going to keep going. We're going to spend some more time looking at the scenario from the other room as well. Okay, so this was the scenario from the room. Andrea, Malavika, and the rest of you folks from that room, would you like to walk us through this? Yes. So would you like to walk us through, how things went?
I could do it, but you know what? I'd love to give the floor to Kat. She's not able to turn on the camera, but she can hear us and speak, I think. Kat, are you okay with that?
Yeah, sure. So when we got together, I had a little bit of a head start because I've seen En-ROADS demoed before, but I had not played around with it extensively, and I came to learn more about it, right? But one of the things that I saw that blew my mind when I first got the tutorial on this was how much energy efficiency has such a dramatic impact, right? So we could make a big difference by just optimizing our energy grids. The transportation of energy is really expensive and way more expensive than I thought it was. So yeah.
Yes, absolutely. Makes sense.
Yeah, but we didn't go in and change anything else. Like this was literally just if no other behaviors changed, but we got all of the utility providers and all of that, and we got all of the construction like businesses to just make what we have efficient, it could have a big impact. And that's before you get into stop using coal, stop using oil, stop using gas, you know. So
Yep, absolutely. And
But
thank you for
I'm
that. I mean,
curious,
go
sorry
ahead.
to
Yeah.
interrupt, but because of the prior presentation by Curtis and your discussion, Ashwin, it seemed that it might not have such a big impact by reducing coal and oil, but much more by increasing the carbon price.
mhm.
Sure. Let's talk about that. But maybe just a few, like maybe a minute or two on why energy efficiency is giving us this outsized impact, and maybe look at a few other charts and see what's happening there. You'll see right off the bat, if you have energy efficiency dialed up all the way to the right on both transport and buildings and industry, you're going to see energy consumption dropping, and that's happening while our GDP per capita is still going higher and higher. So we'll still continue to grow. We'll continue. So in a sense, our lifestyles and the way we live our lives, humanity around the world, that's not changing. We're continuing to grow. More and more people becoming more and more affluent around the world. Hopefully, kind of pulling more people out of poverty as well, raising living standards around the world. And while continuing to do that, reducing how much energy we consume. And if you're able to achieve this, this is amazing. This is really brilliant, right? If you're able to make this happen. You're also seeing the overall energy demand kind of decreasing, dropping. If you remember in our baseline scenario, this just kept increasing on and on and on, right? So we are going to use less energy. And as we use less energy, the interesting thing to note here is the renewables band doesn't really grow beyond a certain point, right? So if we've worked only on energy efficiency, yes, we will use less energy, but a lot of that energy will still come from fossil fuels. So imagine a scenario where this fossil fuel, these three bands on the bottom, the coal, oil, and natural gas, were replaced by renewables, right? So we are using less energy. We're still continuing to grow. And the energy that we consume comes from just renewables, right? So let's, for example, see what happens if we do this, right? If we incentivize renewables. Now, unfortunately, that by itself doesn't help. And why is that? That's because when you incentivize renewables, you'll see the cost of electricity, the cost of the green line just goes really low. The overall cost of energy reduces as a result, and our consumption starts growing again. So what we were hoping for was this green wedge would replace these other three colors. But instead, if I replay that change, instead, our overall energy use grows. And yes, fossil fuels reduce, but just by a little bit. So we are not really replacing. Yeah. So in addition to incentivizing renewables, we might also need to do something like this. We also might need to kind of disincentivize fossil fuels, in which case our energy consumption reduces, and we have replaced a lot of use of fossil fuels by renewables. Yeah. So again, I think the insight that, for me at least, that came out of doing all of this so far was that number one, there's no one silver bullet. We have to do many different things to be able to get to what our goals are. And just incentivizing one thing usually doesn't work. You have to kind of think of a holistic picture of what needs to happen. Andrea, you had a question? Go ahead.
Yes, I was noticing before you went to the energy supplies, so with just the transport, buildings, and industry efficiencies, the sea level rise change was minimal. But when you added the energy supply costs, the sea level rise went down much more dramatically. I was wondering if you could talk a little bit about that.
Yeah, sure. Happy to do that. So let's look at that chart by itself. So this is sea level rise, right? And let's go back to kind of the baseline. Now the sea level rise is dependent pretty much on warming. The warmer we get, kind of the more we are going to see sea levels rise. So anything we do that impacts this temperature is going to give you an impact in terms of sea level rise. So when we pulled energy efficiency, our temperature came down to 2.8 from 3.3 to 2.8, which is what kind of gave us an impact in terms of sea level rise. Now, if you add, so for example, let's tax coal, oil, and natural gas, temperature came down from 2.8 to 2.5, which meant that the sea levels rose lesser. Put in more renewables, that will give us a little more impact. So basically, it's directly correlated with the temperature rise. If the more impact you're having on temperature rise, the lesser the sea level will rise. Does that kind of answer what your question was?
Yeah, perfect. Now I'm sitting here and thinking, are there charts to show what happens when the sea level rise is threatening, like Vanuatu and certain places are basically being threatened to just wash away at this point. But yeah, just
So either,
want to keep following the thought for another hour or two. This is
no,
so
I'll show
scary,
you.
but fun.
I'll show you this. I mean, it's loading. It's going to take a moment to load, but there is also a sea level risk flood map, and you can go to whatever place you want and
Could
look
you go
at.
to Puerto Rico if it's convenient with the bandwidth and time?
Let's try. Let's try. Yeah. So let's maybe look at a few of these island nations. Sorry, it doesn't seem to be. Oh yeah, there you go. So here's Puerto Rico. As of now, it doesn't look like. I mean, there's this small blue on right on the coast, which is land at risk in Puerto Rico. Since there is not a lot of land at risk, even like, for example, even if you pull the carbon price to all the way to the right, we're not going to see a lot of impact. Maybe we should pick some other place other than Puerto Rico. What do you folks think? Maybe let's pick the eastern seaboard of the US. Let's see, yeah, here, for example. Sorry, just zooming out a little bit. So this is the coast of Louisiana. All of this land is at risk. If we get 3.3 degrees of warming by the end of the century, whatever you're seeing in blue right now, and I mean, I don't know this for sure, but I'm assuming this is a heavily populated region of the US. It's going to be land at risk. But let's say we pull a few levers and we get some impact going, and we reduce the temperature down to below 2 degrees. Let's see what happens to the land at risk. It's loading, so we'll give it a moment. Yeah. So does it show any impact at all?
Yeah, it
No,
did.
doesn't look. It did? Okay. Let's see.
Sorry, I was looking at the temperature and all the, how far in the blue was I? I'm a dingbat.
No, that's good. Yeah, we're just exploring, and it's not as if I know the answers either. But the point is that there is this map available, and you can actually look at this map and look at the place that you live in, or if you have, like, for example, Bombay or Singapore, or a few other, big New York, for example, places where we would expect flood risk as a result of sea level rise, and if you have impact on the sea levels, what might happen, right? So that's an interesting thing that we can definitely look at. What else? What other questions? Anything you would like to see us try out? Yep.
So I just had one question, which was when we do the efficiency increases in transport and buildings, when you added some levers on renewables, there was an impact on cost, which I didn't quite catch. So I was
Understood.
wondering.
Okay. So let's look at that. So
Yeah,
let's
yeah.
say we've pulled energy efficiency all the way to the right. Let's look at the smaller graphs. And you're saying that when we pulled renewables to the right,
Yeah, and
what
then
happened?
it was the cost had decreased, right?
Cost of energy, yes.
Cost of energy. Okay.
Yes.
So this is sort of like a optimal situation, or
Well, here's the thing, right? Let me pull back the energy efficiency once and let's look at only renewables, right? So I'm going to pull the renewables to the right. Yeah. And let's see what happens to cost of energy. Yeah. Just pulling renewables all the way to the right reduces the cost of energy. And why is that happening? Because we're subsidizing green energy, right? We're subsidizing renewables. And you're seeing, so this green line here on this graph is cost of energy. So in the near future, cost of electricity coming by renewables is actually going to zero. We're saying we're giving so much subsidy to green energy producers. It's like free energy almost, which means overall cost of energy goes lower, but it also means our overall consumption of energy increases. So we aren't, so ideally what should have happened was this green should have replaced all these other three colors here at the bottom. But that's not happening. We're just increasing the amount of total energy that we end up using. And you'll see the energy consumption graph going up. It goes up marginally, but it does go up. Now, if we add in energy efficiency to it, excuse me, so then energy consumption comes down. The cost of energy is still lower, but we still use less energy in the future. Now, whether this is optimal or not, again, the reason I'm not making like broad statements of what might be optimal is because we haven't really thought through all the justice and equity implications of what we're doing here. We haven't thought about co-benefits either. So that's another thing that we have to keep an eye on. Like, for example, let me show you an example of that. So going back to our baseline scenario, and let's say we pull carbon price all the way to the right. So one thing we know happens is it has a big impact on temperature rise. We are able to make like 0.8 degrees worth of impact on temperatures. We are seeing here renewables kind of replacing a lot of fossil fuel energy use. Now, one impact of that was on cost of energy. We looked at this, we saw cost of energy go really, really high. It shoots really up and energy is really expensive through the rest of the century as well. And that means we use less energy. There are equity and justice impacts of this, like we already said, of taking this action. But there are some other impacts of this as well. And let me try and see if I can pull some of those up. I'm sorry, I'm going to take a moment while I look for these. Sorry, this is going to take me a little bit of time. Yeah, so one of the things that we can look at is deaths by extreme heat. So, I mean, this is just by making sure we don't warm to 3.3. We are going to reduce mortality around the world. So that's like a big benefit. And we are not trying to do that by enacting carbon price. We're just saying don't use fossil fuels, but we are getting this co-benefit of reduced or fewer deaths around the world. There's a few other things that happen as well. If I can find what I'm looking for. So there is a graph which shows air pollution. Oh, here it is. So this is air pollution's PM 2.5 emissions around the world. And just by reducing the amount of fossil fuels, so imagine the number of deaths we see, millions of people dying every year from exposure to fumes, exposure to toxic fumes as a result of burning of fossil fuels. If you're able to do, or if you're able to reduce how much fossil fuels we reduce the temperature, but this is an additional co-benefit, mortality from the dangers of pollution, air pollution, that reduces drastically as well. So whenever we're pulling any of these levers and whenever we're trying any of these interventions, there are these few things to think about. What are the equity and justice implications of this? Are we making life more difficult for some set of people? And if we are, then how can we counteract that, right? How can we enact other complementary policies which reduce that impact? So that's one. And are there co-benefits? Are there other things? So this is, what's called multi-solving. You take one action, but you have many different benefits of that action. So trying to solve multiple problems using the one same lever. All right, what else? Anything else you'd like to see or kind of think about?
I'm
If not,
interested in
yeah,
this
sorry, go ahead.
notion.
Yeah.
If someone else wants to go ahead.
No, go ahead,
Okay.
Andrea.
Yeah. And the notion that with the temperature rising, so if we're at 3.3, that means humanity is really struggling already. And so for the life of me, I can't understand why corporations don't understand it. I'm concerned about the incoming president of the United States withdrawing from the Paris Climate Accord and, incentivizing coal and oil, which is basically what he's literally saying just yesterday that he's going to do. So with the temperature just rising, it's possible the temperature could rise faster and sooner because of, unknown factors, but also because there's so much pressure from all the forces at once, not just the CO2 and the, extreme use of fossil fuel, but the population boom, the migration, the flooding, the fires, and so. So I'm interested in what I guess I'm interested in the analysis you're giving us. This is really fun and fascinating to me. I'm not sure I was formulating my question there quite
No,
specifically.
we can try model that a little bit. So this does allow us, like, for
Okay.
example, what if we go the other direction? Instead of taxing coal and making or disincentivizing coal, what if we
Okay.
incentivize coal, oil, and natural gas? So we will get more warming. What if we then say allow our population or incentivize population growth, for example, right? That has a little bit of an impact, not a lot. And then what if we say we're going to supercharge growth, right? We're going to kind of double down on fossil fuels and we're going to, encourage growth. GDP growth, like, means everything to us. Let's say we're going to like continue growing and really go crazy on growth. You'll see our energy use goes, just continues increasing and it's accelerating even as we're exiting the century. Temperature instead of 3.3 is now increasing by 3.8. And there's like a whole host of other graphs that you can look at, which shows us things getting worse. I'll show you something called the Kaya graphs. And this is a really, really interesting concept. I'm going to take a minute to explain this. So how much warming we get or is dependent on how much CO2 we emit, right? So the chart here on the right is telling us how much CO2 we emit as a result of our energy consumption. And this number, how much CO2 comes from energy, is actually a multiplication of 4 factors. And those 4 factors are our population, how many people are on the planet, GDP per capita, right? How much GDP per person existing on this planet, how much GDP are we kind of producing every year? How much energy do we expend for that GDP, for producing that GDP? And then the carbon intensity of the final energy. So any levers that we pull impact all of these graphs, and multiplying those first four graphs gives you how much emissions we get from energy. I'll kind of go back and reset all the graphs. So for example, let's say we double down on growth, right? We say we need to grow way faster, right? If we pull the lever for economic growth all the way to the right, you'll notice nothing changes on the population front, nothing changes on the energy intensity or the carbon intensity, but GDP per capita grows really, really high, right? Really fast. And that means that our CO2 emissions from energy increase because our GDP has grown really fast, and that gives us warming. What happens if we reduce population? Let's say we pull the population slider all the way to the left. So our population kind of starts coming down earlier, and we peak at a smaller number. None of the other 3 graphs change, but we'll still see temperatures being impacted and CO2 emissions being impacted, right? So I think this is a really interesting concept. This is like an interplay between 4 different factors, which leads to emissions, and the emissions then lead to warming. So I don't know if I'm directly answering your question, Andrea, but I felt this was kind of related to what you were asking about.
No, you got me completely. And now I understand even better how to play with the data and create scenarios or, visually demonstrate to people that are more visual learners that, okay, don't believe in the science, just, look at some numbers and look at some charts. Like, what does that tell you?
Absolutely.
Although I don't know if I convince any climate deniers, but.
That's fine. I think the objective may or may not be just trying to convince climate deniers using this tool. but this does let us play around with our own mental model, just saying, I felt very strongly about something, and then does it really have a real world impact, right? So that lets us compare those two things. Malvika, what did you have?
Sorry, I might be jumping, but I just wanted to know, like, what are the different types of graphs? Because I see you move between graphs and view. So
Sure.
is there some rule as, if
So
you're thinking about a certain kind
yeah,
of information, where do you go?
yeah, I think so. Number one, there is no rule, of course. I mean, they have like a huge bunch of graphs sitting here. I'll go into that a little bit. For just the whole thing is using this tool is an exercise in learning for me as much as it is for you. I'm no expert on this either, and I have played with this a little bit, but I don't call myself an expert by any length of imagination. So what I would suggest is just kind of familiarize yourself what different kinds of graphs exist, and I'll show you a few of them. But then as you're playing with some of these levers, maybe pull them one at a time, and then go and explore what happens using different graphs. And the helpful thing is all of these graphs will show you what was the baseline scenario before you pull that lever, and now what has happened as a result of you pulling that lever. So you can kind of think critically about many different dimensions of whatever action it was that you were taking. Like, let's take an example, right? We haven't really touched this new zero carbon as of yet in whatever we've talked about. Let's kind of pull this all the way to the right, and we'll think about what that means as well. Right? So we've had a huge breakthrough in our energy supply. Maybe there's a research laboratory somewhere in the world today which is working on a new way of kind of getting energy. Maybe it's nuclear fusion, maybe it's something else. And let's say that energy source comes online, and now we're going to get kind of a zero carbon energy source coming in the future, right? So let's replay, or actually let me pull in those miniature graphs, and then I'll replay the change. Let's see what happens. Yeah. So in terms of sources of where our energy is coming from, you'll see the new one, the yellow line, kind of kicking in towards the middle of the century. So we are still in 2025, which is somewhere here, but the new energy source only kicks in 2050 or thereabouts, and then it starts accelerating. You'll see overall energy demand continues to grow. So you'll see our energy consumption is higher than our baseline scenario. Fossil fuels is still not completely being replaced. In fact, I'll replay this one more time. You'll actually see the renewables kind of getting pinched. So we are using fewer renewables, and we still continue to use fossil fuels. We would have hoped that we would replace these three instead of replacing renewables, but that's not happening. That new source of energy is really, really cheap. Again, this is an assumption, but if it were really, really cheap, this is what we would get, and of course, lower emissions. Now, in terms of what else this might mean, you'll see that this source actually starts coming online only in the second half of the century, right? And you can actually go in here and look at or play with those assumptions, right? So, for example, there's some detailed settings in here. In which year, like how many years does it take to commercialize this, right? So right now, the reason it's coming online only kind of in the second half of the century is because we've said it's going to take 20 years. So if you make this, let's go really aggressive, let's say 5 years, yeah, and then pull this back to 2037, you'll start seeing impact coming in sooner, right? So the one thing that you're kind of have to play around a little bit with is what are the assumptions underlying whatever actions you take. What are we saying here? We are saying we are going to get a new source of zero carbon energy, and it's going to come online in the next 5 years. And we are going to see kind of significant amounts of the energy coming from that new source, right? Like sooner rather than later, and that will give you more impact. So again, this is just an example and illustration, but you can actually go into the 3-dot menu on many of these different things. There are lots of settings in there, lots of graphs up here. And I think this is more of a journey of exploration and learning. And I'd like really, really strongly encourage you to play around with this whenever you can. I know we have just about last 3 or 4 minutes left. I just wanted to do one last thing before we finish. We thought about many different kinds of interventions right now. So based on what you've seen so far, or based on whatever you thought of before, I'm gonna ask you to think about maybe the top 2 or 3 things that you would like to see happen in terms of solutions. Maybe it's more renewables, less fossil fuels. Maybe it's permaculture or agriculture. Maybe it's carbon removal. Whatever it is, right? Whatever in your mental model, what are the most impactful things that we need happening? Just think about those top 2 or 3 things, and spend a few seconds in reflecting on what might the world look like in that future, right? If those 2 or 3 things were to come to pass, we are able to get those done in the next maybe few years or a decade or so, what might that world look like? So I'm gonna kind of like we're gonna stay in a zone of silence for the next maybe 1 minute. Just reflect on what might that world look like, maybe a couple of decades from now. So I'm gonna go to mute and stay. Okay, I hope you folks had a chance to kind of think of that future and that world. And the reason I wanted us to do that for a little bit of time was because what En-ROADS shows us is a few different things. It tells us, number one, it's not going to be easy. It's clear, right? It's just moving 1 or 2 levers doesn't really give us a lot of impact. Even the things we felt are going to be impactful, like renewables, just moving that by itself is, really doesn't give us a lot of impact. So it's not going to be easy. There is no silver bullet. There are lots of different things we will have to do in many different kind of areas for us to reach our climate goals. But En-ROADS also tells us that it's possible, right? For example, if you pulled all of these levers and we're still not able to reach that climate goal, that's a different scenario altogether. En-ROADS shows us that it's possible. It can be done. Just that it's difficult does not mean it's impossible. It's difficult, but it's still possible. It's still feasible. And that, that world that you folks just imagined maybe a minute ago, that is within reach. That is possible for us to get to. Now it's on us. It's up to us to figure out what needs to be done to make sure all of those things happen and we're able to meet our climate goals. But remember that it's possible and it can be done. It's up to us now. It's up to us and people like us, people around us, to make sure that this actually happens. I just wanted to say thank you for all of you, to all of you for showing up today and being part of this, and for all the discussion. Like I said, this is a learning journey for me as well. So I'm learning with you all. And I think I learned quite a few things today along with you. Thank you so much. And if there's any last questions, I'm going to hang around for maybe a minute longer. If not, I hope to see you in one of our future sessions. Thank you so much, and bye-bye.
Sorry, Ashwin, I have one quick question.
Yeah, go ahead.
I just wanted to know, like, how are organizations working on climate using this tool?
Yeah.
So,
So the folks at Climate Interactive, actually, that's a good point. Let me give you a little bit of information about that. Climate Interactive, who built this tool, so they have a whole training called Climate Ambassador Training, and you can sign up for that and do it by yourself. They also encourage, they also do workshops all around the world. Terra does some, but Climate Interactive does a whole lot more. They do executive education, they go into boardrooms, they go into government agencies, and they do presentations using this tool. And the whole hypothesis is just using a PowerPoint and telling people what needs to be done is usually not impactful, but sitting them down and actually helping them think through what are the different solutions and what might work and how much impact it might have. Is much more powerful in helping people change minds. So Climate Interactive does a whole lot of that. They go into boardrooms, they go into government organizations, and you can start contributing to that as well if you choose to, by becoming a climate ambassador, by doing the training. I'm in the process of doing the training myself, and I hope to become a trained facilitator soon. So that's possible. But you like we did this workshop here today. Imagine you're able to do this workshop for people around you or people in your organization, or even the community, right? I feel like there is a whole lot of potential for us to do a whole lot more on that. Does that kind of give you some context?
Yes, yes, it does. Thank you.
All right. All
Mhm.
right.
Okay.
Any more questions, folks, before we finish up? All right. So then thank you for coming, and I'll see you around. Bye-bye.